There we are. Good afternoon, Chris.
Good afternoon. Is it afternoon for you?
No.
Thanks. Well, good morning to you then.
Thank you. Yeah, I work with people all over the world so often, and I have since, I don't know, early 2000s that I've finally gotten to where I remember to use the right greeting. I used to be a Novell NetWare administrator. That was one of my first jobs.
Oh.
People probably don't know what that is, but I always had it in my head. There, you had this like message of the day thing that you could do in Novell Network or Novell NetWare, where you would print something when someone booted, and you would type "good greeting time." So I always think that when I'm
just a generalized greeting. Nice.
Yeah. So anyway, thanks for being here today. We're going to talk about smart contract modularity and look at some code. I am an old developer who's done a lot of work in different languages and has always been interested in software design and refactoring. And I am pretty clueless, not a total noob, but I haven't really worked hands-on in smart contract development. So I am looking forward to learning from you. You want to tell us a little bit about what you do, who you are, what you do?
Sure. Oh, thanks for having me first and foremost. I love coming on these and just talking about things I've been working on. So I work at Violet. For those that don't know, I'm the founding engineer, and at Violet, our mission is to evolve trust. So we have a lot of efforts going on in the identity space, the decentralized identity, and we want to have a take on it where we kind of re-inject the notion of trust into what we feel like is a domain that has either lost touch with it or has misunderstood how to best use it. And so for us, the mission is to find a way to reimagine and evolve trust so that it's something that is probably a bit less of a touchy topic, especially in Web3. And my role is mainly on the protocol side, whether it's smart contracts or off-chain stuff. A lot of my time is spent doing design, research, and implementation of some of these new approaches that we're trying to pursue in the pursuit of what we think is a better decentralized identity system. I guess that's it. Personally, I have a background in physics, so I think a lot of my thinking there helps with abstractions, especially, and different kinds of design patterns to fit, I think, what we might need, and especially in the crypto space when we have to deal with a lot of new and emerging primitives. Just being able to get your head around each of these building blocks and understanding the implications and the effects it has is really important in making sure a system is robust, especially for all the actors in the system, which is what we care about in Web3.
Yeah, I've had this observation for many years now that when I get into a totally new technology or framework, it's like I lose all of the wisdom that I've gained over the years for some period of time. Right. And I just start spewing spaghetti code, even in production. And then then something clicks, and I think this is a terribly designed system that I'm building. It just because it's a new technology doesn't mean that I shouldn't follow the instincts that I've developed over the years. Right. And when I saw, I guess back in February, you all posted something about your extendable pattern and library. I thought, of course, people are doing this sort of thing. It's necessary. And at first I had sort of a cynical view, being an old software developer, like I like to say, that, okay, you're just reinventing the things that already existed. But as I've learned more about smart contract development, especially when it comes to like security vulnerabilities and cost of gas fees and all that stuff, I realize it is a very different environment. So we'll start to see familiar patterns of modularity and composability, but they do need to be very carefully tailored to that environment.
Yeah, I think you touched on an important point. I think there is a lot of reinventing because I think from a high level, a lot of concepts might seem similar or related, but then once you get into figuring out where the details change a potential implication late down the stack and why you might need to change the way you think about something or redesign a common design pattern, then you realize, why it was so important to do that, to make that step and reinvent it. And I think reinventing isn't necessarily a bad thing all the time. Obviously, you do want to stay with the tried and true a lot of the time, but I think it should also be advised by your new domain, especially when you work with new technology. You know, what's different about what you have today, and where does it call for kind of a bit more innovation on one side or another. I think having a cynical view is good, because I think you really need to understand what makes this beneficial. Well, why do we need this? Why do we need to use this? And I also had a bit of a cynical view on especially modularity as well. And I think it comes from a crypto native view of smart contracts and the feel of immutability. You know, you want your smart contract, when designed and written and deployed, to be just that as you deployed it. So not only do the users, your stakeholders, they're always sure of what they're interacting with, but that also you kind of you do away with the idea that there is some central party in control that can kind of change these different aspects of a smart contract. And so immutability, well, by itself isn't in conflict with modularity, but definitely modularity is best used when you can change things and make things flexible. And I think with the advent with a lot of DeFi applications that are becoming more and more complex, you're already seeing a lot of the kind of protocol designers already build in the notion of upgradability as part of their protocol, because it's so complex. They do need, first and foremost, the ability to patch bugs. And we've seen a lot through the hacks. There have been a lot of catastrophic losses due to certain software bugs. And either you code with immutability in mind and do a lot of upfront work ensuring that there are no bugs, and you can never fully be sure that there are no bugs. You can just kind of get a asymptotic approach to a certainty, but you'll never really reach certainty,
right?
That there are no bugs. But you can increase the probability that there are none. But because there's still that potential of having bugs, the need of being able to patch them and change the contracts whilst deployed is a big requirement. Especially as you see, smart contracts are much more composed. A contract might touch 7 different protocols at once, and so can you really be sure if a user uses it in one particular way that you didn't think of, will it still hold, or will it collapse in a completely unforeseeable way?
Yeah. So backing up a little bit, this is something that has, when I first heard about how smart contract systems would work, around the time Ethereum came out, I guess, it made me very uncomfortable, because I come from a background, like I was part of the initial wave of agile software development, extreme programming, and like my brain is geared toward thinking I'm not building physical architecture, I'm not sending people to space, I'm building business systems or whatever. They're mutable. And when something is mutable like this, you should change your perspective from trying to stop everything from happening, or every bad thing from happening, to being agile in the face of issues and being able to then fix them quickly, right? So like I often talk about optimizing for mean time to resolution instead of mean time between failure, to use like a systems metaphor here. And with smart contract immutability, that becomes very scary. And so scary that in my head, I thought, I'm glad I don't do that kind of work, because I don't want to have to deploy things that can't be changed. But what you're telling me is there are immutable pieces, but the systems as a whole end up being somehow mutable through various patterns, including extendable pattern, right?
And yeah, that's the general idea, because exactly what you touched on. I think there's a tension in the space where you start from a world where you want to really value immutability, but then as products start getting built, the thinking that you mentioned about being able to be agile and being able to either add features or be able to fix things, and like reducing the mean time or increasing the mean time between failures, and being able to hotfix and just be mutable has its benefits. And that's crept in as we're building more and more products, because there is a user base, and we do have value propositions that we need to fulfill. And so that's why we see kind of now the advent of a lot more mutable smart contracts through upgradability patterns. And what I guess I want to introduce is a more nuanced and more modular and flexible view of modularity through the extendable pattern, where, like you said, we can still make use of immutability as a benefit without it restricting the power which we have in building complex applications whilst maintaining the safety that we've grown to love in Web3.
Mm-hmm. And just so that, if there are other listeners like me that aren't experts in this field and are just curious about blockchain development, smart contract development, the value of immutability in this case is that when you're interacting with someone or something, especially when it's doing something maybe financial on your behalf, you need to know and trust what you're interacting with. So it should be a version that at least someone has checked and it hasn't changed sort of randomly under the covers, right?
Exactly.
Yeah. I was working with a security company over the last couple of years that does JavaScript, like front-end JavaScript security. And it turns out that mutability is one of the biggest issues with front-end JavaScript security, whether like malware on the web, popovers, phishing attacks, etc., that you don't know what you're dealing with out on the web. You've got all these dependencies, and maybe your library or your application is under your control. But there are so many dependencies, and you end up with all these like mutable things. You don't know what they are. They're not content addressed. There's like weak stuff in the web, like what's it called? Integrity hashes, that sort of thing. Sub-resource integrity checks is what they're called, where you supply the hash of something, and they're just really weak workarounds for a serious problem. So that is the motivation of the immutability aspect. But then, as we said, it creates a bunch of issues.
Exactly. And I think just like on that point, I think a lot of people are worried about, the things that we've seen actually in practice, like DNS hijacking, where like state bodies can like spoof certificate authorities and redirect, people to a completely malicious website, either to collect data or to surveil you. But that's kind of the immutability that people want. If I see the lock in my browser, I want to be sure that at least the same Google that I'm used to knowing, and that it hasn't changed under the hood. And it's the same with smart contracts. If I put my funds at risk and I stake them or I lend them, I expect that the functionality of made available to me to retrieve them again still exists, and not that somewhere down the line someone's removed that. And that's been, I think, one of the problems that I think that's the main arguments against mutability and upgradability of smart contracts. At the end of the day, I think frameworks like this, the Extendable that I'm about to introduce, it's a tool at the end of the day. These aren't like guardrails or rules. It's a tool designed to help developers express more complex applications where they need to. And it still can be used badly, like a lot of other tools. But we try our best to, one, prescribe a standard procedure for usage of them. We try to describe all the pitfalls, whilst also making sure, okay, here are a few sets of things that we've built in to the protocol or the pattern to make it less easy for people that are used to normal smart contract development to fall into. So this is a few of the things that we try and do. So
cool. Should we look at some code or something?
Yeah, sure. So going back to talking about smart contracts and upgradability, first thing I want to go into is what things look like today. And I'll give an example of the ERC-71. So I think if you can share my screen.
I just did, yeah.
Awesome. We've been working a lot around NFTs in Violet. And so I thought ERC-71 is a good token stand to look at with this. And what this is what an ERC-71 contract looks like. You have a bunch of variables. You've got the name, the symbol, blah, 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 and all the functions. And so this whole contract would be developed by a developer, probably OpenZeppelin, because that's what everyone uses. They will be rewriting this. But what they will be doing is they'll be redeploying it themselves. And what that means is you end up with this entire contract, another one on the blockchain alongside the millions of other ERC-71s. And so immediately it seems, couldn't we save on a lot of that gas cost, that precious gas cost of having to redeploy something? And we could also save on potential errors. So if people aren't using OpenZeppelin and everyone's maybe looking at the EIP or using other libraries to draw their implementation from, each implementation could have its own errors or their own problems. And if we could find a way where there was a more standardized approach, a more standardized reusable approach to deploying the same contract again, wouldn't that be great? And
a clarifying dumb question for you. So
yeah.
ERC 721 is the standard which defines an interface for creating non-fungible tokens.
Yes.
Right? And then you said that you wouldn't recode the implementation of this interface from scratch. You would reuse someone else's code, like the OpenZeppelin one. Which does that effectively just pull in the code as dependencies and bundle it up in the contract so that when you deploy it, you're deploying their code along with yours? Is that how it works?
Essentially, yeah. A lot of people almost don't even have their own code. They kind of deploy the ERC-721 vanilla as OpenZeppelin implemented. But entirely right. So ERC-721 is born from EIP 721, which was a Ethereum improvement proposal to define a spec for a non-fungible token interface. And exactly what you said, the implementation thereafter is done on a case-by-case basis, and the most popular implementation is OpenZeppelin.
Okay. And then when you deploy the vanilla one, you're just passing in these variables when you construct it, so you don't need to write your own code. Okay.
Yeah. So when you deploy, you would specify, this is the name of my token. I can call it Papa Smurf NFT symbol Pap, and then the rest of it would also be customizable. Like I can adjust the owner, let's say, so only I can mint because I'm the owner of the contract. Also like sorts of things like that. Those are kind of configurables that you would pass in during deployment of an implementation.
Cool.
And so in practice, what you end up with is various instances of these that are kind of configured differently. But in the case of wanting to add a feature, let's say maybe I want to add an additional transfer feature, or even like what's a good one? A lend feature. Like I want to lend my NFT to someone. I can't do that. And the only way that traditionally kind of contract updates have been done is through the proxy pattern. And so what this is instead of now the interactions with the contract, where previously if I wanted to mint the token, I would call this contract and I would call the mint function here. What ends up happening is the function calls are routed through a proxy. So this becomes the facade of your contract. This is the contract that gets called, and the implementation of the functional logic gets housed in this contract here. And so when I want to call mint, it goes to the proxy, and then it goes, I know which contract it has the implementation, and calls the function here. In this way, there's a clear enabler of upgradability, because instead of pointing to one contract, you can point to a new contract. So if you wanted to add a new function, or if you wanted to fix a bug, you would deploy a new contract and then tell the proxy the new implementation lives here. And this is how upgradability works. It just says, abandon the old one. Here's the new contract that houses all the new business logic. And
this is also an OpenZeppelin thing, right?
Yeah, so it's popularized by OpenZeppelin. Their proxy is, I think the idea was, someone came up with it that wasn't from OpenZeppelin, but they did harden the approach in the implementation.
I see.
And interestingly, there are some other approaches to proxy patterns done by, I think, Gemini. They had a very novel approach as well to proxies and upgradability. So I think for those interested, I think you should check them out. I think is it the Gemini USD, I think, uses it. But this isn't the most well-known proxy pattern that gets used. It's simply a pointer shift. I now point to the new implementation. As you can see, though, it's a redeployment of the entire contract. So if I just wanted a new function, the only diff being this len function, I would still have to redeploy the whole contract, because I'd develop the contract, add the new len function, and then deploy the entire monolith. And I guess that's what I call monolithic contract development, because no matter what, you've contained the entire contract and all its functionality within a single monolithic artifact.
Right.
That needs to be redeployed and then referenced.
And even when you were talking about the deployments, you used the word instance, like this would be another instance of the ERC's in 21. But in fact, like as an object-oriented developer, instance usually means an instantiation of a thing that is already defined in memory. And in here, what you're talking about is another copy of it, right? You're using the word in English as opposed to computer speak.
Yes.
So you've got all these monolithic copies of the same code.
Exactly.
Yeah.
Yeah, it's a good distinction to make. So it's another copy because it's an entirely new smart contract that gets deployed. It has its own bytecode. It lives in a different memory storage address or account address on Ethereum. And it will contain mostly all the same code as here, bar this one len function. And so I was thinking, not only do we not make use of the rest of the other code that's the same, but we had to incur the cost of redeploying everything just to add a small update. Is there a way we could make this better? And this is what an extendable ERC721 looks like. It's empty, right? Exactly the case. So with extendable contracts, the whole idea is that a contract itself doesn't hold any functionality, features, variables, anything. It's kind of just all it has is the ability to be extended. And what that means is we have the power and the flexibility to decide during runtime and at compile time what set of features we want our contract to have. So in this case, a vanilla deployment of an ERC721 or extendable ERC721 looks exactly the same as any other extendable contract. It will have nothing in it because it's ready to be added with features.
Yeah.
And those features,
it's a named shell
exactly
of the thing that you're going to interact with. Yeah,
exactly.
Cool.
And those features that we want, those functionalities, instead are extended and they live in extensions. And so now what we see is a split of all our previous functions, mint, burn, transfer, approve, and these owner of and balance of functions. They're now split up into separate extensions. And these extensions themselves are smart contracts. And so the benefit is I would implement maybe a mint function and I'd deploy it as its own smart contract. What that means is when I deploy my ERC721 contract, all I have to do is say, please extend this with the mint function and the burn function and transfer and approve and getter. And I'll point to where they live on the blockchain for it to be able to kind of collect its functionality. And now what we have is kind of functionally separated units that I can specify to include. And as you can see, extensions can have more than one function. At its most basic, it can contain just one. But the idea here is you can configure the modularity depending on what your use case calls for. And so as you can see with transfer, I've housed all the functions related to transfer in a single extension. Mainly because maybe for, looking to the future, if there's a bug in the transfer, there might be a lot of related processes in the transfer that affect a lot of those things. And so I just want to be able to update those selection of functions and not touch anything else. And that's the beauty. If I did find a bug, I would now go back to my IDE, redevelop the functions in the implementation here, and then tell the extendable, actually, please point to this one now instead of the previous one. And so what I've been able to do is I've not touched any of the other implementations, and all I've needed to do is perform a simple replacement function by replacing this extension with the new implementation.
Yeah, and just as a clarifying thing, in case anyone is confused, you typed FFF there.
Yes.
The idea is that's some auto-generated contract address, and all the references are to those by address.
Right. Yes, and
Yeah.
so these are placeholder addresses that I've given them. But yes, when you deploy the extension or any contract for that matter, it will be given its pseudo-random contract address. And obviously, when I deploy this one, it will be generated a new account address. And once deployed, I will tell it to please extend to this new one. And that, in a nutshell, is what it is. But obviously, with Extendable, the kind of the line that you draw of where your modules are, like what do you consider a module, is kind of up to you, the developer. Like I put here, maybe I just want to house all the transfer logic here, and I put all the getter logic here. So this is kind of what returns you these view functions that you want to query about your contract. So who's the owner of NFT 0? What's the balance of a particular user? These kind of return types, I say, this actually fits a getter type, so I'll put it in getter logic. But feasibly, you could see it kind of modeled however you'd like. And in this case, you could even see a lot of the token-related functions live in the same extension. So this is minting a token, burning a token, transferring a token. These are kind of all very token tangible features. And someone might decide that's what I would consider a module. And I guess the key here is there's no prescription for how you want to create your modules, and it's kind of up to the developer, depending on their use case, how they draw their lines and what they would consider a module, bearing in mind the kind of additional benefits of what modularity brings you. So kind of standalone units that allow you the upgradability, maybe common features, things like that kind of help you decide what a module might be.
Right, or just the names and like the cognitive load of processing stuff, right? Like
Exactly.
I was talking about I remember when I started doing Ruby on Rails development back in 2004 or so, I started writing Rails controllers, and I realized I'm just putting all of the actions that this web app needs to do in one controller because my brain shut off. And then, over time you realize, well, I should have multiple controllers for things so that I don't have to think about the entire application in one long spaghetti stream.
Right.
And then you say, well, even this controller has reusable stuff from that controller, so let's start mixing in modules, and it allows you to then have neatly bundled named groups of things that are conceptually related. So I think even if you weren't doing you weren't worried about reuse or upgradability, this is still a useful pattern. Although I do have the question now, like in the old world, this basically looks like IOC, inversion of control or dependency injection, which was a concept really popularized almost 20 years ago, I guess, especially in the Java world, where you have a container for stuff, this like extendable ERC 721 idea, and then you start injecting functionality into it, and therefore you can change which functionality is injected. It also allows you to do stuff like mocking for unit tests very easily, that sort of thing. But in those worlds, you're dealing with nothing but just normal in-memory with a single process. So are there costs to doing this? Like, do we need to think about that? Would it be a mistake to always do this if you don't care about upgradability?
Yeah, that's a good question. So there are some additional costs, but they're fairly minor. So a lot of the costs that are a bit more significant are actually very rarely done. So for example, deploying an extension, you wouldn't really do very often. Extending and replacing, so managing this relationship between your extendable contract and the extensions that implement the features, that's added cost really, but it's also fairly rare. I think the most important part is the normal usage of the contract made more expensive through this. And so obviously, if a user wants to call a function, it's now kind of needs to be routed to its module. You find the function and then you call it. It adds a tiny overhead, and I would argue that it's very negligible. And we put a lot of work into making sure that the operational cost, the from the user perspective, which they don't want that to be any different. Otherwise, there's kind of a material difference between this framework, and it's a bit more problematic.
Mhm.
And so we've done a lot of work trying to kind of minimize that cost. And I think I've managed to get it to a fairly negligible degree, so that only the significant costs are now shouldered by, let's say, the management and the maintenance of such a contract. And so it's the extending or the redeployment of an extension, and changing which extension gets implemented. Things like that are where the costs really are. But even then, they aren't so huge.
Speaking of that, we have a question from a viewer. Joe Alba wants to know, does an addition or change to the extensions lead to a new instance of the extendable item? If not, what mutates to repoint to new/different extensions?
Good question. Very good question. So when I said earlier that this is empty, it was a bit of a white lie. What comes in this is already, is what I would call this. No. Cooperate, please. So this already comes with this, essentially. With that, as you might have, for the astute viewer, might have noticed, is we came from a world where we had variables as well being defined under the contract. And what we're seeing here is, where have the variables gone? I'll get to that a bit later, but essentially, these functions will access variables through a storage module. So on one side, we have extensions, which house functional logic. Those are like the functional modules. And then you have storage, which are where kind of these modules define and declare the kind of variables that you'll keep in your smart contract. And so with this, actually, behind the scenes, we have a set of mappings that tell us, for a given interface ID or for a given function selector, where does the destination extension live and what's the contract address? And so behind the scenes, we have this mapping. So whenever a function call comes in, the extendable knows, aha, this function is implemented by extension XYZ, call that contract. And so really, the structure of the contract doesn't change, but there is a variable under the hood that helps you manage that. So whenever you want to replace an extension, you can call there is another, what I'd call a default extension. So we have a few default extensions. One of them is extend, one of them is retract. So what this allows you to do is to remove an extension. And then you have replace, which is a combination of extend and retract. So what replace does is it first retracts an extension, then it extends with a new extension. And so kind of armed with these three default extensions, you have the ability to extend your functionality, remove it, replace it, update it, whatever you want. And so that's kind of how it works. Did that answer your question?
I think it answered his question. We can have him respond, but I would guess so. Yeah, it helped me understand it, and it did actually raise another question I wanted to ask you. I guess then, like thinking about how Solidity works, there isn't any sort of like hard interface for the extendable ERC 721 thing that says these functions must exist and no other functions can exist. With Solidity, you can just call functions and there are like fallbacks in case they're not defined, right? So I assume that's how it works. Okay.
And that's what we rely on actually to achieve this, because let's say at time 0, when you first deploy a set of contracts, you won't really know what other features in the future it will have. And so the benefit of using Extendable also is you'll always have an evolving interface. You won't really, you might not know exactly what you have, and that's what we also build into Extendable. So as the interface of your contract evolves, there's a actually a function that allows you to request what is the current interface of your contract. So you might have many different like functions implemented, or more like extensions, extending your extendable contract. And so being able to query, what do I have, what's implemented by this extendable at any given time, really helps you understand, okay, this is the interface of my contract. And so in this way, the extendable, if you were to do an extendable ERC 721, it would obey the ERC 721 interface as long as it had these set of features as extensions of it. And you'd be able to check if it did or didn't.
Great. So these named things like extendable ERC 721 end up sort of being, they appear to be mutable. They actually aren't mutable because the thing itself, I mean, the code isn't mutable, right?
Right.
And they're pointing, all of the extensions end up being also pointers to immutable representations.
Exactly.
So it's like how Git works in that way, where you have like the latest head of something, which is actually a pointer to an address or content address that looks very much like these addresses by coincidence.
Yeah.
But then you're going to always see every version that was ever deployed because those are actually immutable and can't even
exactly.
Yeah.
So you can witness kind of the changelog of, oh, this extension was removed at this point, or this extension was added at this point. And it gives, I guess, the user from like the immutability point of view a better confidence on, okay, what's happening, what is it right now. They can even check at any given point, oh, is it the same contract that I know about? And that kind of lends itself to making sure that if there are changes, they're trackable and easily detectable. And so you can't, let's say, rug pull someone by adding a withdraw all funds function or a steal all NFTs function after the fact and get hold of everyone's precious PFPs.
Yeah, it's interesting. It seems like now I can kind of think of smart contract development, or at least the model around it, as being almost like an append-only database system or Git, like it's version-controlled code at runtime.
Right. It's almost like it reminded me of a DAG, and it's not quite a DAG. I directed a cyclic graph, and so where DAGs normally always point forward, and so there's always changes that can be made, but it doesn't really apply here because you can use something from the past. But it's definitely something like that, right? It's like an immutable changelog where you can always see kind of the history and know where it has been, know where it is now. And in some ways, I would feel like it kind of combats the problems with mutability, because I feel like the main issues with mutability are the transparency of it. And I think that's why a lot of people grew to hate Web 2 and centralized services, because one, you don't really have any transparency about the processes going on behind it, and two, you don't really have a say. I think these are the main two problems that caused the marginalization of a lot of people and to shift us towards what we like about Web3.
So we should look at some code before we go much farther.
Yes.
I do have a question, though, before we do that. Just one more abstract sort of thing. Should someone create a combination of these ERC 721 features as a set of extensions that get deployed, like the current version of maybe OpenZeppelin's code, and then others should just use those on chain? Like, is that a better way that people should just be doing it? Is there a disadvantage to that?
100%. I would say that's the ideal way to go, because OpenZeppelin's code does get peer reviewed by a lot of people, and it'd be almost a bit more foolproof if they deployed a set of extensions and use their contract wizard as they normally do and say, here's a one-click deploy, and it's much cheaper because we've already implemented it. It's already on chain. All we'll do is kind of grab those extensions in your deployment of your contract. And so,
right, not even grab them, right? Just reference them.
Right, point to it. Go, there it is.
Yeah.
If you want to qualify, there it is. And I think that would be the best way to go, because you have already people relying on their implementation, but you still undergo the redeployment costs. And I think that would be a huge step. And I think it goes to another point as well about kind of version control and who controls the canonical implementation. I see a world going into the future where you could see, let's say, an extendable in itself as an extension. And maybe you have a contract that wants to act like an NFT, but it also wants to act like something else. And that would be your extendable. And maybe you'd reference extendable ERC 721 as a collection of those features offered by ERC 721. And what you kind of use that as is almost like a library. You say, this is the known implementation of this token standard that I want to use. And you end up with, let's say, a more operating system like EVM, where instead of writing and developing code yourself, people that, let's say, may not be very tech savvy can now say, I want to deploy a token and I want to use the ERC 721 program and point to that one. And that program will have its own set of updates because maybe OpenZeppelin maintains that program and updates the extensions that exist behind it. And so what you end up with is kind of an up-to-date implementation or program that you can now import for whatever business use case you might want. And so going into that, I feel like there's a future of modularity where there's community-owned and community-managed implementations of very key use cases like ERC20, ERC721. Even lending pools are like a hot topic, and there should be kind of standardization around the safest way to do those, even staking protocols. All of these can, I think, be standardized through this approach and have a community-managed way of delivering updates, ensuring that DAOs vote on what changes get made, and so you keep accountability and also transparency over these changes.
Yeah, that's an interesting one. You could actually do like a snapshot vote for a DAO that triggers a change to a different version of a library that's a dependency.
Exactly.
Yeah, it's in a sense. Then this is a lot like the difference between dynamic linking and static linking in Unix or Windows development. And there isn't really a dynamic linking standard now. Right. Is there a reason that we wouldn't do what you're talking about? Is there some cost, some drawback?
Yes, and I think it's a social cost because the cost is more than in how do you coordinate around which standard is the standard and how do you manage the stakeholders behind it that maintain the implementation. So you could easily say, OpenZeppelin does that, but then why is OpenZeppelin the arbiter of what is a correct ERC 721? They only are by social consensus because their implementation is publicly verifiable. There's a lot of feedback that goes into it. Their cycle is very rigorous. And what they end up with is maybe on the OpenZeppelin website, but it's a product of many people. And I think if you model that in terms of DAOs and creating DAOs that are well invested in and have a deep interest in maintaining these kinds of libraries, it's just making sure that those incentives do align, because if there is a malicious actor that says, I'm going to change one of these extensions and they have a huge part of the DAO vote, they can feasibly inject very malicious code and cause a lot of damage to the ecosystem. And so that would be one gotcha about that approach. But I think just looking at the way DAOs are developing and the way community is coordinating, I think people are very careful about this, and I think communities can emerge where you have sub-communities or sub-DAOs that say, I'm very interested in token standards. We will peer review and manage this and make sure this stays up to date and safe. And maybe you'll have a separate community that looks at more DeFi-related applications or even more socially related applications.
Cool.
Thanks. Well, you want to show some source code then?
Let's go into some code. So we'll stay on our ERC 721 example. For those that are techie, I can point you to here if you want to do a play along. I don't know if this Can I comment here?
Yeah. Here, you
Is that
put it
good?
in private chat, and I will put it in public chat.
Yeah, there we go. So I'll be working out of this repository, and this is an open source implementation of exactly what we've been talking about, the ERC-721, but as an extendable contract. You'll be happy to know all the features are the same as Open Zeppelin, so I took their functionality and I recombobulated it. I know you like this word. I recombobulated it into working with the Extendable framework. I saw that tweet of yours.
Yeah, combobulate.
Yeah.
We tend to only use the word discombobulate and not actually just combobulate. So
Exactly.
I thought about that. I was talking to my brother-in-law the other day, and I don't know why it came up. I looked it up, and I was like, wow, that means refactor or ameliorate or whatever. So yes, everyone combobulate your code.
Yeah, combobulate your code into extensions. And I'll give you an example of how I've done that. So I'll walk through a bit of the GitHub repo just to show you what the project structure looks like. What you'll see is mainly extendable projects should be laid out like this. At first, you'll have the extensions, a directory, and a storage directory. And extensions is exactly what you suspect. It just houses all the features. And so now what this kind of gives you a view of is literally the kind of contract interface of the token. You have the approve, you have the burn, you have the getter, you have some hooks, mint, the on receive stuff if your contract is a token receiver, and then the transfer. And so just looking at that and the separation, I've gone for the more flexible organization, so the one that looks more like this.
Yeah.
But again, you can structure however you want.
Just more granular.
Yeah. Exactly. And so what that then looks like is this. What does it look like? First, it's a bit small, isn't it? There you go. So first I define, my ERC-721 is extendable. And then I pass it a few things to initiate it. And so what these are is on construction, I'll specify it, the normal name and symbol, but I also give it the extensions about where everything lives. And what that does is upon deployment, it will already have that functionality. So you can either do that during the construction phase, so adding all the features there, or you can do it after deployment. And so really, if you don't do any of this here, which is extending the contract with each of the features, the approve feature, transfer, you can do this afterwards and just call the extend function and pass in your extension address. Does that make sense? I feel like I might have.
Yeah, I think so. So the extend logic thing is what you showed earlier when you were answering Joe's question about pointers.
So what's happening here in this block of code is exactly this: extend, 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 and extend. And this is all happening during the deployment of this contract.
So the extend logic functionality is somehow already inherent in this new extendable thing you've created.
Yeah.
And then in the source code, you were calling extend logic delegate call.
Yeah.
And you were.
So yeah, it's a delegate call. That's a complication, but it's essentially just doing a extend logic dot extend and then your extension.
Okay.
Essentially what it's doing. It's a delegate call for reasons that are a bit more low level. I think probably leave that out for now. Those that are interested, we have a docs page and a blog post that might explain a bit more. But yeah, essentially that's what it looks like. So I think what we can do is actually let's try deploying one.
In the meantime, I'm posting the blog post.
Extendable. So for those devs that are out there, you can play along with me. I'll be able to give you the steps that I'm taking that you can take. So if you git clone this, you can follow along. The only thing you'll need to do that I've already done is make sure your end file contains a private key or a seed phrase that you can actually deploy things from. I'm not going to leak mine. That'd be really dumb. But that's all you need to do, and you'll be set up. So the first thing we want to do is deploy our extension. So we can't deploy our extendable and give it the features if we don't already have those features. And so the first step of any extendable is really first, let's deploy the features. So I'm using Hardhat to help me. And I've written some tasks that can help. So let's have a look. Oh, it's bigger than I thought. So this is what we're looking for, yarn Hardhat and network. I will do this on Kovan, and the command we're looking for is deploy extension. And so the first thing I want to do is probably deploy extend logic.
So is this task included with the modules that you add, or do you need to add this into your project?
So if you cloned the repository, this will have it directly. If you're writing your own project, you'll have to copy the tasks that I've written from this repository into yours. Okay. Arguably, it's almost easiest to start writing your project out of a clone of this one because everything's here for you, and just add your contracts here. Alternatively, you can do an import. So you can do a yarn install, and we've got it as an npm package as well. I can probably point to that. Yeah, here we go. So if you want to use it in your own project, you can also just do a simple npm install here. Violet protocol, ERC71 extendable, and it gives you access to all these primitives. So here you can just say token is ERC721 and you're good to go.
Cool.
But yeah, like you discovered, these helpful tasks won't be available unless you clone the repo here. So first off, we've deployed our extend logic, looking good. Now, what do we need? Approve logic. Let's deploy that too. So this will be a bit of a boring section. So you can kind of talk about anything whilst I deploy all of these.
Would it be useful to look at one of them while they're deploying, just to see what I don't want to derail you.
Yeah. So here is what a extension looks like. It looks like every other contract you've ever seen. And that's intentional. We want it to feel like you're still developing a normal contract. The difference is we add this inheritance. We call it, this one's internal, so I can give you one that isn't internal. Oh, this one's internal too.
Does internal mean only usable in this context versus published for others to use, or?
Yes, good question. So internal basically means it's an extension that will likely be called by other functions in this contract. And so what that gives us access to is a modifier that can specify some functions as internal, which means only callable by this contract. And so it basically prevents external callers from being able to call the contract.
Cool.
So it's all that really needs to happen is you define your contract as an extension, you write your functionality, and all that this extension bit means is you need to add an additional step where you define your interface. And so, for example, here we have the additional features. And so all that means is that you need to define your getInterface ID function and the getInterface function. And these are kind of the introspective functions I mentioned earlier. So if you wanted to check what interface your contract currently has, these are the functions that help you do it.
Okay, makes sense.
And so other than this additional step, writing an extension is just the same as writing any other smart contract. Nice. And so the one I deployed here, approve logic just now, this is what it looks like. It has the approve function. So I approve the spending of this token ID to this address. These are some approve steps. So I can approve someone to spend a token on my behalf. and our staple boilerplate here for an extension. A side note for those watching that are devs, this interface here has changed in the new version. So look out for that. We haven't released the new version yet, but it should be coming within the next couple of weeks. So this will be a breaking change, FYI. So the next one we want to do is getter logic. And here getter logic looks like this. Return me the balance of, get me the owner of, get me the approved user of, is approved for all, exists, and is approved to owner. So going back to internal extension, by marking something as an internal extension, we get this additional modifier, underscore internal. And we similarly put an underscore in front of those functions too. And what that says is only this current contract can call this function. So it's useful for those functions that are more like utilities that are used by your other functions rather than things that you wish your users will call.
Cool. But I do see what you mean. If you're familiar with Solidity code, then and you open one of these, it just looks like normal Solidity code, and there's nothing.
Right.
There's almost nothing discernibly different.
Yeah.
You just split up the monolith into multiple named modules.
Exactly. And so it's with Extendable, it's more a mental shift in the way that you would approach it, because when you think about now coding your smart contract, really the first thing is, what does my interface look like? How can I split the functional units into separate modules, and in what way would I do it? Like I have here with ERC-721. And then once you have this is basically your interface. You go into actually implementing the functionality of each extension.
Yeah, you could almost say you want to categorize the sets of behaviors of the smart contract.
Right.
And then you implement the categories as new extensions.
Mm-hmm.
It's good. I mean, I already sort of think that way anyway when I'm organizing my thoughts around the code.
Right.
So it's not really even an extra step. And I guess if you feel like you're doing something unnatural by going through this step, maybe it means your contract is succinct and focused enough that you don't need this.
Right.
Then you could use the proxy pattern for just doing straight upgrades, I suppose.
Right, exactly. And I think, yeah, you mentioned a good point. It's a good mental exercise. I think if you jump right into coding, you might end up creating architectures or designs that might not be as elegant as you might think, but then almost doing this mental exercise of splitting things up gets you to think about, oh, how can I make this more efficient, or how can I simplify this? Or if it's a bit too complicated, maybe that's a sign for you to simplify some things, or divide it even into more parts. So I think it's a good mental exercise when you kind of shift your thinking away from monolithic development and into modular and extension development.
Mm-hmm.
Right, so all these have been deployed. Let's deploy the ERC-71. So have a look at my commands again.
So if you tried to deploy ERC-721 without having deployed all of those, would there be some error?
Yes, because when you do deploy like this,
mm-hmm.
it will say, hang on, you haven't given me this variable. So let's call it Chad's token. Actually, would you like for me to call it that? What should I call it?
Chad's token's fine, yeah. There's probably already a Chad, and well, in fact, I know there's a Chad NFT because they sent one to the wallet. What a terrible name I have.
Oh no. You're a total Chad there. I respect you.
I don't know what that means. I don't think it's good.
Ask the Gen Z. It's kind of Gen Z slang.
I looked it up on Urban Dictionary in like 2011, and I wasn't pleased, but I'm sure the meaning has changed over the years. That was 11 years ago.
Right. So as part of the deployment, we need to specify obviously the name of the NFT, the symbol, and here's when we start it starts asking us to provide the extensions. And so
Okay.
extend will be the first one because it needs to know where the logic of actually doing the extending comes from. I think approve is next, which is here. Then it's better, which is here. Then it's on receive, which is here. Then it's transfer, which is, I'm blind here.
Yeah. So these are all, or this is, you're calling your custom task that you've created for this project.
Yeah.
Which is basically going to pass these into the constructor when it gets deployed.
Yes.
Yeah. Okay.
So it'll basically, what I'm doing is every single input here are the inputs to this constructor here.
Yeah. Okay. Cool.
Demo effect.
Yeah. You've been interrupted the whole time, so surely something's going to blow up. But even if it does, I think we understand now.
There we go.
Oh, wow. It worked.
Deployed 2. So for those that want to check it out, you can paste that in the chat. That's the contract address of the extendable on Kovan. Contract creation, here it is.
Cool.
And what you'll notice is if you look at transaction details and click internal transactions, a lot of things are happening. And this is the extending step of all the extensions. And what you'll see is actually it's not that expensive from a gas point of view. And you would expect, with all this extra kind of management and referencing and stuff, that it would cost a lot. And actually, I think it only costs about 40K gas to do the extending. So that's...
Is that not very much? I always get lost in these numbers, these gas numbers. Like what's expensive and what's cheap?
That's a good question. I think someone should maybe come up with a metric. I might call it the Uniswap index or something, because Uniswap v2 is notoriously expensive, but people still used it a lot. So if we can figure out how much it costs to do just a basic swap. I can't find any Uniswap transactions. I would go by a Uniswap transaction as a metric, but I would call it cheap for the functionality that's occurring, especially when it's a one-off. It's not very cheap. I think some transfers will cost around maybe 300,000 gas, 200,000 even, depending on how many hops it takes to get to the token you're trying to swap.
Okay, wow.
I'm not sure if that's super accurate, so correct me if I'm wrong, but I think that's the ballpark. Anyway, that's deployed. So I think the next thing to do is let's try minting.
You're very brave.
Yeah, I am. Let's see what this gives me. There we go, token, and I need to pass in this address. So I'm specifying where the token address is, and I'm specifying our extendable contract. They're probably asking what token ID and which address. Yes, recipient. I'll use.
So now you're deciding who gets this?
I'm going to... Actually, does chat want to give me an address?
I don't know how long the delay is. It may take some time.
Okay, I'll send it to myself because I'm a fan of chat NFTs. I'll give myself the first one ever. Is it just ID?
I like that you just type things and let them be wrong and let the error message tell you.
Here we are. Yeah.
Error-driven development. I'm a fan.
it doesn't like it.
See, that's why I said you were brave.
And
We don't need to mint it necessarily. I think that the concepts are here in the code.
Yeah, so let's pretend it worked. Ooh, we minted a token. Ooh,
well done.
Well, it worked.
You're the proud owner of a Chad NFT
Yeah.
on a test network.
And that's pretty much it. The thing is here is we interact with the contract just how we would interact with a normal contract. We can just expect this contract has the ERC-71 interface, call the mint function or call the transfer function. So mint isn't strictly part of the ERC-71 interface. But whatever interface it does have, we can utilize that to execute a function call, and it will behave just like a normal contract. Bar one thing, which is Etherscan doesn't have support for extendable contracts yet. So when you, like, for example, this one, I've done a transfer, the contract itself won't show you exactly what that looks like. Whereas on a normal NFT contract, it'll tell you, this is an NFT contract.
Yeah, it'll give you the token name and all that stuff.
Exactly, yeah. Maybe there is one. Actually, is it this one? Deploy. Anyway, there's a few things that we can do to get around stuff like that, but I think that's one of my next goals. I would love for Extendable to be adopted enough for Etherscan to implement some additional helper for Extendable, just like they do for proxies. So you can view contracts as a proxy on Etherscan. I'd love if we could view contracts as Extendable, and it could show you all the extensions it has, and yeah.
Yeah. So if you're watching this now and in the future and you like this, please use Extendable and complain to Etherscan that it doesn't do what you want.
Right. So yeah, basically, and now we have an ERC-721 token that has completely separated functions. If I wanted to replace a mint function, let's say, I can do so. I think it's important to note that, especially with Extendable, the management of which extensions can be added or removed is down to the way that you implement your permissioning pattern. So the default for ERC-721 is the permissioning of having a single contract owner. So what I can show you is what we use.
Meaning, so if anyone wanted to swap out the minting functionality for an upgrade or a different implementation, it would have to be the owner, the original owner.
Yeah.
Did it. Yeah.
So if I show you what the mint looks like here, so basic mint logic. Oh, that's got nothing. So permissioned mint logic. We have an only owner or self. And so what that does is it retrieves the storage state. So this is one thing I think I didn't talk about actually with Extendable. There is some storage that uses, actually, that's one thing I should show. But let me finish this point. So right now we have only owners or self, so the current contract can do the minting, and it's the same with extending. And what that means is you can either use this default permissioning. Can't find it now. There it is. Where we define an owner, and that owner owns the contract, and only the owner of the contract can do certain things. Or you can specify a completely different permissioning, right? So you can specify roles, you can specify maybe even a DAO to do that. But let's get into the storage side quickly.
Because everything we've seen so far has been about behaviors.
Extensions, exactly. And so it's a good segue. So with permissioning, our default permissioning model is to use a single owner. And so this default gets used by the extend logic too. So currently extend logic at its default state requires the owner, which is the deployer of the original extendable. It sets that as the owner of the contract, and only that person can extend the contract with other things. And that's defined like this. And so there's this parity between extensions and the kind of contract state that it intends to interact with. And a lot of that gets defined eventually by the actual functional logic, because let's say with the ERC-721, when you transfer or you mint, you're always doing it over a certain token and a token ID. And so you have to hold that somewhere. And so that kind of helps us define what variables we want. And in case with the permissioning logic, we want to be able to record who the owner is at any given time.
Mm-hmm.
And so we do it like this. And so this is what we call the storage library. And this is how you would define your variables using the extendable pattern. So traditionally, let's use an example. Traditionally, you would, let's use this as an example contract. You would have some variables defined here, some uint. And that's how you would be defining your variables. It'd be in the scope of the actual contract, so that when you define a function, this is how you would access it. So the reference to your variable is here. And that's how you would make this link. And this can't be done with extendable because, as we saw before, until we really extend your contract, we don't know what you're trying to interact with. We don't know what the features are. And so what that means is you develop your storage module, your storage library, kind of hand in hand when you develop your extension.
Right.
And that's what we're seeing here. So because I want to create a permissioning logic module where I restrict functionalities to only owner, I can set the owner, get the owner. I create a struct which defines what variable I want to store. So instead of having that uint value here, I could specify here. So some uint would exist here instead.
Yeah, I like this because it forces you to separate storage out, not by policy, but just by how the technology works. Right?
Exactly. And so so whereas when you would have a monolithic contract before, you might have 7 or more different variables declared at the top of your contract. And it might not be clear, actually, where do those variables get used? And are they used everywhere, or is it only in some parts? Mm-hmm. With this, it's very clear. Okay, this variable is very much to do with permissioning, and that's where it exists.
So what would happen if we set variables in the extensions? Seems like that would be a bug.
It would be. It would be. It wouldn't necessarily be a bug outright, but it does raise the potential for what we would call a storage collision.
Right.
And
if multiple contracts are extended with the same extension, then they would be sharing storage if you did it.
Exactly.
Yeah,
exactly. And
that would be bad.
That's kind of the problem. You want to declare these as separate storage instances and reference them as independent modules. Whereas if you declare them inside the contract, you end up with a potential of referencing the same part of memory or storage address of the contract, and that can cause issues. Because let's say you have one extension that puts the variable here. The way that Solidity works is that at compile time, the contract gets this variable gets assigned a address, and it's incremental, starts from 0. So this variable exists at slot 0. If you have another extension that declares something, no matter what it is, that will also exist at slot 0. And now if you have these 2 extensions that are now being extended by your extendable, it won't know what variable exists at slot 0. And so you end up with this collision, which can cause bugs. So if you start writing to that variable and then rewriting it or reading it as a completely different type, you'll end up with a completely corrupted data set, which is why we use storage modules, where now we have a nice little house for your variables to live. And its extensions simply import this library. So we call it permissions. Probably better if we call it permission storage. But in this case, we define a get storage function. And this is boilerplate. This is something that what I can show is actually storage template. This would be basically identical for for anyone wishing to write their own storage module. The difference is you define your own struct to contain those variables, so you can do whatever you want. And then importantly, define your own identifier. And this is the most important part, because the way that an extendable contract identifies storage address is through this unique identifier. And in the permission storage, this is what it looks like. So we call it extendable.framework.v1 : permission state. The reasoning here is because in order to avoid collisions, we have to kind of pick something that's pseudo-random, and that low is kind of the risk of collision. And we do that by operating on a certain specific semantic. So using this kind of syntax helps us create human readable names that are predictable from a human readable point of view, but once you follow a syntax that gets hashed, so we hash it, that hash becomes that pseudo-random factor that we use to say, okay, let's pick a random slot in this slot. And we use the kind of guarantees of what Ethereum assumes as low probabilities of hash collisions as our strength in making sure that these storage slots where you write data don't collide with each other. So in permission storage, we have this. We might be only holding one variable, but for extendable storage, and so this is the behind the hood variables that I mentioned earlier about how Extendable keeps track of which extensions are where. This is what the extendable state looks like. So we have a list of interface IDs that are being implemented, and then where those contracts exist. And here our reference is slightly different: extendable state instead of permission state.
Right. And this is a convention that your team follows. When you say we, that's what you mean, right? Yeah. So you could say anything you want here, but this is a good thing to copy.
Yeah, and the idea is because later on, when you've deployed your extendable, there'll be many other people writing their own extensions. They'll be defining them differently, and they'll also define a different place in storage where they'll exist. If you make something very generic, like, I don't know, owner, for example, that's very prone to collision, because it's very likely that someone else will pick something that's just as simple as owner for their identifier. And what that will mean is their extension will be referencing a given slot for their variables that they've defined for those features. And you will also be doing that too. And so you'll be kind of competing for, or not even competing, you'll be straight up colliding with that storage address.
Yeah.
So by picking something like this, and I say we, because it's something that it's still decidable by a user, but we advise on making sure that you pick something that's going to be fairly unique, a format like this where you can also track which one. So in case you change or you add an additional variable, you can say now v2, and it won't be colliding with the previous version storage. And it's mainly reasons like that that can just make using extendable a lot easier, when you can know with a human readable name, these variables live at the extendable state slot. And so what this looks like is, so let's go back to our permission storage. So what this looks like from the extension point of view is simply this. I import both the known variable structure type, so that's role state, which is this struct, and I import permission storage. So this is previously called permissions. And so in my extension, I import both the variables and the library. And whenever I want to access that variable, I call permissions.getStorage, which returns me this struct, which is this function here. So permissions.getStorage returns me that struct, and I access the .owner property of it. And so that allows me to both read and write. So with this variable, so for example, here, if I do update owner, I'll fetch the role state, again, by doing permissions.getStorage, and then set state.owner to the new owner that's getting passed.
Mm-hmm. Yeah, I see why you had to do this for technical reasons, but I also like the side effect of the fact that all the storage stuff is in one place. It's all bundled together. very clear what you can and can't do in terms of storage.
Mm-hmm. Exactly. And you're very, very, very kind of intentful about which variables you're using. Because in this case, you have to be clear that, oh, I'm getting the storage from the permissions library, or with extend, I might be getting storage from the extendable storage.
Mm-hmm.
And so it means that you're very intentful about what state you're accessing. And this is kind of one of the contracts that I do both. I'm getting the owner to make sure that who's extending the contract is always the owner. And for here, it's about fetching what the current interface is. And so I get that from the extendable storage.
Cool.
And so that's how you would code a storage library. And it's pretty straightforward. This is copy paste essentially, other than putting your own naming scheme. And then defining your variables is just done in here.
Nice.
Yeah.
Anything else that you want to say about the whole project?
So I guess we at Violet, we're going to be the first port of call for something like this. So this did come out of some work that we did where we realized we needed kind of this reusability, or at least the abstraction away from known interfaces, and a move towards a potential where we might not know the interface of a contract because a user will decide during runtime what extensions they would like to have and what features they want. And so this stemmed kind of from our idea around credentials and creating user-defined credentials in the kind of decentralized identity topic, and allowing a user to be able to use a framework like this. And that's where the ERC-721 kind of comes in, because we in some views we can model a credential as a non-fungible token. And what that means is our credential can take the form of an ERC-721, but it can also have its own and carry its own other features, like how does issuance of a credential happen? How does verification of a credential happen? And these are kind of what we see as extensions, right? These are the user-defined features that we might not know at runtime. And so it kind of was born from there. And we are, I guess, really excited to see what the community thinks about, one, modularity going forward, based on kind of, is there a need for it? Is there a clear indicator that complexity can be solved with modularity? Or is it also about making sure that there is the ability for more flexible user-defined features? Is there a clear need for this thing that I call the Ethereum operating system, Ethereum OS, which is having these libraries as DAO-governed programs that now users can kind of import and use however they like, and be sure that the implementation is hardened and peer-reviewed. Just kind of, and other applications, like potentially like writing DAOs using Extendable. You might not know what features or functionalities your DAO community might want until later on, and so using Extendable could allow you to evolve as your communities evolve and as the use cases and applications evolve. So
yeah, this was the unexpected, inspiring idea from this session for me, is the idea of what you're calling the Ethereum OS, like runtime libraries sitting out there ready just to be used, immutable and owned by a trusted contract or a trusted wallet, for example.
Right.
Yeah, it's a really interesting idea. I'd love to see where that goes.
Yeah, definitely. So that's kind of it. That's the basic ups and downs of the Extendable. I hope I haven't missed much.
I guess I posted a link in the YouTube stream to the blog post announcing it, which also links to GitHub and your docs.
Right.
So anything that you might have missed, which I bet there isn't anything too serious, should be accessible there, right?
Yeah, and we're currently pushing through a current documentation update. So it will be a refresh on some of those topics, and it goes a lot more in depth into how exactly Extendable works under the hood. It talks a bit more about delegate call. It talks a lot more about storage and collisions, And it does provide some guides about how to write your own extensions, how to write your own storage modules. So the current docs you might see will be slightly out of date, but the refresh is coming in very soon.
Great. Well, thank you so much. This was fun.
Thank you. Definitely.
And thanks for watching.
Thank you, guys.